All right, let's get right into it. If you're putting together an AI rig, you've definitely hit this crossroads. Do you go all out for the absolute beast, the RTX 4090, or do you grab the shiny new, super efficient RTX 4080 Super? Well, today, we are gonna settle that debate. Welcome to the ultimate AI GPU showdown.
So here's our game plan. We're going to kick things off with the quick verdict, no waiting around. Then we'll dive deep into the power under the hood and talk about the all-important VRAM bottleneck. After that, we'll see how these cards actually perform in the real world. And finally, we'll look at price, power, and all the practical stuff to help you make your final choice.
Okay, first up, the quick verdict. We're not going to make you wait till the end for the answer. Let's get it right now.
You know, it really all comes down to this one simple question. What are you after? Are you trying to squeeze out every last drop of performance, or is getting the best bang for your buck the name of the game for you? Your answer right here is going to point you to the right card.
And here it is. If you just need raw, unadulterated power, if you're working with bigger, more complex models, and you want to future-proof your setup for what's next, the RTX 4090 is your undisputed champion. But if your focus is on efficiency, keeping costs down, and running really well-optimized models, then the RTX 4080 Super is an absolutely killer choice.
All right, so that's the high-level view. Now let's get into the nitty-gritty and look at the raw numbers that actually explain why one is the powerhouse and the other is the efficient contender.
You know, the secret sauce behind both of these cards is NVIDIA's Ada Lovelace architecture. And as NVIDIA themselves say, the new Tensor cores are just unbelievably fast. This is the core tech, the engine that makes both of these GPUs such monsters for AI tasks.
Now this is where it gets really interesting. How do we measure that AI power? Well, we use a metric called AI TOPS. Just think of it as the raw number of AI-specific calculations the GPU can blast through every second. And as you can see, it's not even close. The RTX 4090 just storms ahead with over 1,300 TOPS, compared to the 4080 Super's 836. This is a direct measure of its raw AI muscle.
Let's look at another key metric, T-flops. This measures more of the general-purpose computing performance. Think of it as the GPU's overall mathematical horsepower, which is absolutely crucial for things like training models from scratch. And again, the 4090 just flexes, with around 83 T-flops to the 4080 Super's 52. For any job that's heavy on the math, that difference is huge.
And this slide right here, this shows you where all that power comes from. It's the CUDA cores. The 4090 is absolutely jam-packed with over 16,000 of them. The 4080 Super has just over 10,000. It's simple, really. Think of these cores as individual workers. The 4090 just has a much, much bigger workforce.
But hold on, raw power, all those cores, that isn't the whole story, especially not in AI. There's one resource that can be even more important, and that's memory. So let's talk about the VRAM bottleneck.
The RTX 4090 comes with a massive 24 gigabytes of super-fast GDDR6X memory. Go ahead and burn that number into your brain, 24.
Because the RTX 4080 Super, it has 16 gigabytes. And that 8 gigabyte difference, trust me, it is one of the single most important distinctions between these two GPUs.
Okay, so why is this such a gigantic deal? Well, VRAM is basically your GPU's workspace. It's where the AI model itself, plus all the data it's crunching, has to live. And here's the kicker. If your model is too big to fit in that workspace, it doesn't matter how fast your GPU is, it just won't run. More VRAM equals bigger, more complex models. It's as simple as that.
All right, enough with the specs and the theory. Let's talk about how all this stuff actually plays out with the applications you're probably using, like generating images with Stable Diffusion or messing around with large language models.
So for image generation, here's the good news. Both of these cards are absolutely fantastic. The 4080 Super is more than powerful enough for most of us doing creative projects, but if you are a professional and you need to generate super high-res images or process huge batches of them at once, the 4090's extra speed and VRAM give it a really clear advantage. Now, for large language models, this is where we got to have a little reality check. That VRAM bottleneck we talked about, it hits hard here. The 4090, with its 24 gigs, can handle things like fine-tuning a smaller 7 billion parameter model, but the 4080 Super 16 gigs, let's be honest, that's just not enough for most serious LLM work. If you're really serious about large-scale training, you're in a different league. You need data center hardware like an A100 or H100.
Okay, we've hammered on performance, but a GPU doesn't live in a fantasy land of benchmarks. Let's talk about the real-world stuff that hits your wallet and your power bill. price and power consumption.
This table right here, this is basically the whole story in one shot. It lays everything out side by side. You can see the 4090's massive lead in VRAM and compute power. But then, look at those bottom two rows. The 4090 needs a whopping 450 watts of power and launched at $1,600. The 4080 Super, it's way leaner at 320 watts and a much more palatable $999.
And this chart just visualizes that trade-off perfectly. With the 4080 Super, you're getting a huge break on both the upfront cost and the ongoing power drop. And that 130-watt difference isn't just about your electricity bill, by the way. It also means it's easier to cool and it'll fit into a lot more PC cases without needing a crazy power supply.
So, we've seen the specs, we've looked at the benchmarks, we've talked about the practical costs. Now it's time to bring it all home and figure out which one of these GPUs is actually the right one for you. Here's the bottom line. You go for the RTX 4090 if you need that absolute maximum performance, if you're handling huge datasets, and if that 24 gigs of VRAM is something you just can't compromise on for future projects. On the flip side, you choose the RTX 4080 Super if cost and power efficiency are top priorities, if your work is mostly running models that are already trained, and if you're generally working with smaller, more optimized AI.
We've covered a ton today, but really, this is just scratching the surface. All the info for this breakdown was sourced from Best GPUs for AI. If you want to go even deeper, check out their website. It's bestgpusforai.com, and we've dropped the link in the description for you.
So there you have it, the absolute powerhouse versus the smart, efficient challenger. Now that you know the score, the choice is yours. The only real question left is, what incredible things are you going to build with it? Thanks for tuning in.